Welcome to the Diff, where we ask, what if we could redesign everything? And in today's session, we're going to be explaining how we redesign everything. Hello, my name is Seb Reed. I'm a member here at the Diff team, and today I'm going to be joined in the Diff studio by an educator and designer who works at Autodesk Foundation, Steve Parkinson. And we're going to be talking about the future of making, how new digital tools unleash new possibilities for today's young designers. We're going to be talking about design education, opportunities for young people to express themselves differently in the future of the world, the circular economy, and many other things. What we really want is for you to join in that conversation as well. And there are a number of ways you can do that. You can do that by using the comment space that we have here on the Diff webpage if you're watching there. There's also a comment space on the YouTube stream if you're watching via YouTube. And you can also tweet us using hashtag ThinkDiff. So post your questions, your comments, and we'll be challenging Steve with those as the session goes on. Okay, so welcome Steve. 45 to 50 seconds. I wondered if you could give us your Wolverine-style origin story. How did you get to the point where you're sitting on this sofa with me?
Well, it's great to be here today, and it all started for me as a secondary design and technology teacher. About 15 years ago, I pursued a university course where I wanted to be a teacher. I knew I wanted to work in education from a really sort of young age. I then was a design and technology teacher for about 10 years. Part of that involved me meeting people at the Ellen MacArthur Foundation, where I learned about the circular economy. That genuinely did inspire me to want to do something different, and that's why I'm working at Autodesk today. Along the journey, I did work for, I knew I needed to do something different. I knew I needed to change careers. Went to be a deputy head at a school, made the complete wrong decision, knew that wasn't for me, and then ended up working with Autodesk, which is very much about the future of making things and that next generation of how young people are going to inspire and change the world.
And there's this sort of story we still tell at the foundation about some of your work with us, where you worked with a student and they talked about the circular economy and how actually that mindset shift, they went from not really knowing what to do to being, actually it's kind of where our catchphrase come from, being like, oh, now I can redesign everything. Yeah. So there's something about this idea that's kind of inspiring for young people.
Absolutely, and I remember having that conversation with James. And he just said to me, look, last year, sir, I couldn't think of anything I wanted to design. And now you've introduced me to the circular economy, I've learnt about it, and now I look at everything, and everything does need redesigning. And it genuinely does have that impact then. And I was at a university a couple of weeks ago talking about the same thing, and exactly the same impact then as well. So it's a really powerful message.
And so I think what we're going to dig into a bit today is this idea that, so then you've got the new mindset, and you also need some tools, and there's a real opportunity today, I think you feel, and certainly we share a lot of that during the Diff, that maybe there hasn't been before with technology. And in particular, I think your work involves around something called generative design. Would you mind telling us what is generative design?
Yes, generative design is a, how can you explain? Generative design mimics the way nature's evolutionary design process, in the way that it starts with a designer putting in some information into the system, into the computer. That would be things like caseload, how much stress does it need to take, how much does it need to weigh, what materials do we need to use, what manufacturing methods have we got available to us. All that information goes in at the start of the process. Then the computer, using the power of the cloud, comes up with hundreds, maybe thousands of different iterations. And the clever thing with this is every iteration that's created by the computer then goes back into a feedback loop. So it learns from the designs that it has created, feeds them back into the iteration, and then it builds on and improves again. So you're left with lots and lots and lots of different design iterations. Then the design engineer comes back into the design process and carries that forward.
So is the idea that it's called generative design because it's kind of you give data and information to generate design?
Yeah, absolutely like that. It's biomimicry. You know, it copies the way in which our bones grow. Exactly that. And what you're doing there is you're giving the computer the science, and then what happens is like our bones grow, like nature's evolved. You've heard of form follows function, form over function. Well, in generative design, form follows forces, and that's exactly what it's doing there. But the key thing with generative design is it gives you lots of ideas, thousands of ideas, which ordinarily you would never have thought of. And also it looks like something's been grown rather than something's been designed and made. So something quite different there.
So for any designer, anyone who's in the audience who's not a designer, form follows function?
Yeah, so that comes back to some basic design history. Form follows function would be where the way something works and looks. So the way something functions is the most important thing, and form over function would be you start with the aesthetic, how does it look, and then everything else after that in terms of how you mechanically create it is secondary. Form follows forces, literally uses the science and then optimizes its way forward.
I think you've actually got some examples of this that we can actually talk through and show the audience a little bit more
so
what it looks like.
As a bit of an introduction to generative, the typical way in which we would design something, in this case here, let's say a chair. You would design the chair, I've got the idea in my head, I know what I want, I'm basically documenting that on a computer. I'm happy with how it looks. I'd probably take it to the next stage where I put some finite element analysis on there. So what I would do is I would test that. Is it going to take the weight of the average human or the 97th percentile or whatever it is we're measuring there? If not, I would iterate that myself. I'd go back in, I'd make some changes, reduce some material, add some material, change the shape. But with generative design, having put all them parameters in place, for example, you can see in the bottom right-hand corner there, weight, what material, what machines we've got available to us, the computer, using the power of the cloud, can generate all these ideas for us, and after all these ideas have been created, the design engineer can go in and can say, right, actually, I want this to be stackable, so let me focus on those designs. Actually, I want this to be made from titanium, so let's look at those designs and refine there. So what it does is it cuts out that iterative part for the designer, and it certainly isn't replacing the designer or the engineer. I very much think, and this is the way it's been used with students, is it's augmenting that process. So we've got a computer and a student working together.
So what were we sort of seeing there when those chairs were flashing by? Is that just the many different iterations that the process is going through?
Absolutely. So each one of those is an iteration, and the key thing to remember there is that feedback loop. So every time it creates an iteration, it learns from how it can be improved. That information goes back into the system so that the next iteration to come out is that little bit better. And then what we can then do is we can refine that as we go along. But yeah, the real advantage here is using the cloud, and that comes back to the disruptive times that we're in. We call it the future of making things, where we've got a convergence of lots of technology, cloud computing, new ways of manufacturing things, consumers' demand changing, and the things that they want from product all coming together to be able to give us the power there via the cloud, which we wouldn't have been able to do this before on a normal desktop computer.
And that chair, I guess, looks kind of like a chair, but also there are some differences.
Yeah,
it looks kind of skeletal.
You know, that chair, the key thing with this is obviously we want to be able to make it. And this is the output of that chair. This is the what we call the elbow chair. But that's actually been manufactured.
Why is it called the elbow chair?
I don't know the reason for it being called the elbow chair. I know it's part of our body, but I think the key thing, if you look at that 10 years ago, that would like be something from a science fiction movie. And what's happened there is because we've got the convergence of the cloud, new technologies like generative coming onto the scene, and then we've got things like robotic arms being able to hold a router on the end and being able to get into places which wouldn't have ordinarily been able to manufacture. We end up with products like this, and it's nice that this is made from wood to perhaps represent that organic, homegrown shape.
Because actually, intuitively looking at that, and maybe it's because I'm prejudiced from the fact that I have this preconceived idea of what a chair should be in my head, it almost looks like I haven't got very much back support with that chair, for example. It's like, I guess it just shows you how different.
Absolutely, and that's really, really interesting point, because this is where, you know, computers don't have emotions, they can't see things, they can't see aesthetics that me and you can see. So this is where working with a designer is as important. Now we'll see a little bit later, but the designer has quite a lot of control at the start of the process. So they can say, well, actually, I do need material in this place for a backrest, for example. I do need material in this place, so obviously I'm not going to fall through. You know, I need to sit on that surface. And then, of course, obviously in this case, we've got 4 legs, which does represent how a typical chair might be.
So it's possible that the computer could decide that actually you don't need something underneath to hold you up.
This is why it's critical that the designer or the engineer has that information. If you don't tell the computer enough, the computer won't know what you're trying to achieve. So there's a different skill there. There's a skill shift from actually, rather than CAD, where computer-aided design, you had the idea in your head and then you transferred that onto a computer. Think of CAD as not as computer-aided design, but computer as designer. And what's really important there is if you want the computer to be a designer, you need to give the computer the information it needs to design something.
Because obviously CAD is a term and a concept that's been around for many years.
Yeah, and this is moving beyond that. This is what I would consider an advanced design and manufacturing tool, because design and manufacture themselves are converging and they're coming together. And if you've got good enough information at the start of the process, in the design process, for example, here, you can manufacture anything.
And how are students actually tackling this then?
Yeah, so every time I talk to students, there's exactly that the wow factor with the circular economy. There's 3 things that students get really empowered by and excited. That's circular economy, that is generative design, and it's user-centered design as well, which is, they're the 3 things that I'm really seeing students get excited about. And I wanted to talk to you first of all about a student over in Germany. This is Philipp Manger, who's at the University of Applied Science in Jena. And what he's done here, this is what we'd call our first level of generative design. So it's not generative as we've just spoke about, but it's a great introduction to what students are doing now with tools that are completely free to them. And what he's done is he's used something called topology optimization.
Topology optimization?
Yeah, it's a nice easy one there to remember.
What does that actually mean?
So topology optimization is the fundamental principle under generative in a kind of way. What you would do here is you would say, right, I need some 5mm axles to hold the wheels. I need 4 mounting holes on the bottom of the skateboard in this instance, and then everything else is up for grabs. And effectively what it does is it works out exactly where the forces are going to be with all those parameters that the designer has put in. And then what Philip will do there is augment that, and he's worked with the computer to be able to come up with this organic shape. Now there's just one, and Philip's in complete control of those iterations. It's up to him whether he goes back and goes through that process over and over again, not the computer. But also what he's done as well is he's used them tools, and you can probably see just inside there the lattices. So this is a product called NetFab, and what he's done there is very, very similar to how our bones are made. Our bones grow, not made. If we were solid bones, we'd evolved over time, right? We'd be very inefficient. We'd be dragging ourselves around. We wouldn't be very agile. Made that hollow.
Some of us still aren't, Steve.
Absolutely, right? So that's made it hollow. So there's parts in there. Them lattices are less than 1 millimeter in diameter, and that then adds that strength and back to biomimicry. Replicates exactly how we as humans and animals have evolved.
And so what James has done here is he's he's input some data into the computer saying, I've got a skateboard, I've got one particular part I want to optimize with certain parameters. So he's given it some restrictions, but he hasn't said, I want to redesign the whole skateboard. Is that right? No,
not the whole skateboard. He's specifically looked at the parts. So this is actually called Project TOAST, T-O-S-T, Topology Optimized Skateboard Trucks. So that's a skateboard truck that we see there. Now the other thing to add to that is with generative design or with topology optimization, it's fine to be able to get to that point, but until, in this case, selective laser sintering, 3D printing, so using a laser beam to melt metal, that wouldn't have been possible. And it's just a really exciting time. The future of making things is all about all these technologies converging and coming together at once. There's a lot of stuff out there, and students are really, really well placed to explore this and really put the digital tools to the test.
So without 3D printing, that would have probably been some sort of flat block. It wouldn't have had the sort of aerated structure that almost looks like it has there.
If I'm a CEO of a casting company now, I'd be looking at that and I'd certainly need to be concerned, or look at and think, well, actually, what do I need to do differently? How can I embrace this technology? And also, how do I embrace this student? You know, I've got the student coming through, doesn't want to work for me. He wants to work for himself. When he creates his own skateboard company, or whatever it might be, or his new casting, you know, what do I do there? And that's the real challenge. And I really do see this disruptive, working with a lot of students, there's a disruptive wave coming through, and we're ready to disrupt.
So this is one step towards generative design.
Yep.
I guess there's examples of students or projects where it's gone a step further.
Yeah, so I just want to show you the next one. So this is actually something which is fresh this week, and we've got a programme in the UK for secondary schools actually called isgenerative, where we get students to use digital tools to design and 3D print a quadcopter, a drone.
I'm glad you said it was a drone. I'm glad you said actually at the moment that diagram means very little to me.
Yeah, and this is where we've completely flipped the design process. It's quite interesting. So on there, what you've got the red areas, which we need to preserve. So we need them red areas need not have any material in there. You can see you've got multiple arrows in there where we've got certain forces, and they're going to be there all of the time. So we need to tell the system, in this case Fusion 360, exactly where those forces are going to be.
When you say forces, what's that, like air pressure? Or
yeah, absolutely.
Just the natural...
It could be from when the drone's landing and the force of its own structure. It could be, you know, the fluid dynamics of that air coming through. All of those need to go into this study here. The red areas are where we've got things like propellers and blades. You know, we can't have material there, otherwise that can't circulate and move. And when we've got the green area, where we need material there because that might be regulation, depending on what it is. And we put all that in, and then what comes out is this. So this is
skeletal type structure, Steve.
Yeah, it looks like. I mean, I look at that and I think, obviously, I can't see how it could be an animal, but if you look at how bones, when you look at a bone, it just looks so similar to that. And that's that idea of, you know, form follows forces. It's looked at the forces, and it looks at where it needs to have material, and then it's created that drone quadcopter chassis there.
It's kind of like nature meets the world of future technology, isn't it?
Absolutely, and you know, that idea of biomimicry and learning from nature to take us into this next generation of design.
What are the advantages of this particular design?
Okay, so this design actually is a lot lighter than it's difficult. So what we've got is, first of all, you would design and make something, we call it parametrically. So you would create, and right, I think I need that much material, and you put it under a load. What's happening here is, because the computer's been left to design this using the principles of nature, it's come up with something where it just needs the amount of material that it has. So it doesn't need any more, doesn't need any less. You can change the parameters, so the aesthetics, for example, and that quadcopter may well need to slot in with another quadcopter. But ultimately what we've got a lightweight reduction there, hugely lightweight, and then we've also got something that's potentially a lot stronger and a lot more mechanically fit for purpose than what something designed in a traditional design process would have been.
And I guess it's just not, without the support of this sort of technology and this big data, it must be extremely hard for a designer to just think this up, or, you know, even to get that far to really radically innovate in this way.
Definitely, and I think the key thing here is the data acquisition. So this is really early stages, and this is data which Mark Chester, who we've been working with at Autodesk to produce this program, has got himself. Obviously with quality sensors, if we've operated this drone and put sensors on this and we were having real-time data coming back into the system, then that's going to create that agile product development system. We can use that data and we can improve that on the next iteration as well. And you can just see along the bottom the different types of iterations of where we start. Each time that gets better because generative design cross-references the previous design to learn from it and improve.
So what we're seeing along the bottom there is a progression from this to what we see at the top.
Absolutely.
That actually feeds into a question that we've had from Eves, who actually was sort of asking about this, is could you please explain how the feedback on each iteration is given to the computer cloud system? Is it based on AI? Which I guess you're kind of saying the technology is giving the feedback.
Absolutely.
Rather than we're giving the feedback to it.
So what's happening there is each time a iteration is being created, it's effectively doing that analysis of those stresses and strains. So the loads that the engineer predefined, it's running that analysis on that particular iteration, and then that's feeding it back into the system. And we're doing some really cool stuff at Autodesk with AI. And one of the things with AI is how robots can have eyes and sensors and thermal sensors and that type of thing to improve manufacture. So wouldn't it be cool if you could, with machine learning, a robot could start 3D printing or building something, but then know through its eyes that it was going a little bit wrong, that the thermal camera eye said that it's cooling a little bit too quickly, so it needs to respond, and that's the sort of stuff there we're doing with machine learning.
That sounds like another really quite big step towards this sort of technological future that we're often discussing. Kind of comes back to the point you're making earlier about the role, what it does to the role of designer in the world where you've got this technology thing. I think there's also like a kind of linked thought to that of like what sort of comes first, the mindset shift and what you're looking for, and or the potential that you just realise that this technology can do something crazy and let's have a play with it.
Yeah, I think this is why it's really interesting working with students, because this technology is new. Things like additive manufacturing are new. The idea of robots being able to make things is new, and it's all happened in this generation where we've got students coming through the system. And the answer to that is these students are using this and they're exploring, and they themselves are coming up with these answers. You know, they're answering these questions. So I was speaking to some students up in Manchester a couple of weeks ago, you know, and fair enough, we've got a computer designing things, which is great, but I would always, you know, are the robots coming to take over our jobs? I would say absolutely not. But I would say working with robots, working with computers, and the human with that emotion, all augmented together, is certainly for me where the future of making things is going to go.
Quick tip to the Diff audience, by the way, there is a podcast on tomorrow, being released tomorrow, or maybe Friday actually, about, it's called A Designer Bot Works Along a Designer. I think it's called Karen Anders and Karen or something like that. Search for it on the Diff schedule because it's touches on many of the themes we're talking about here. Let's see another couple of examples of...
Yeah, this is an amazing image, right? It is
an amazing image.
Yeah, this is Jaron, and Jaron's from the Glasgow School of Art in Scotland. Now, you look at them and you think, well, them spectacles, I'm never ever going to wear them. And that's not the point. The point here is Jaron wanted to make a statement. And he wanted to say, look, he's definitely made a statement. He wore them to a conference we had back in Copenhagen earlier in the year, and he certainly wowed the crowds with this. But the real sort of fundamental sort of idea behind this is, I spoke to Jaron about generative design. 2 weeks later, he'd created his own generative algorithm by himself. You know, he thought the power of this was unbelievable. And what he's done there, he's using one of our products, Fusion 360, he's taken the idea of, you go for your spectacles, you buy them off the shelf, and you if they don't have your size or they're not quite right, you've just got to put up with it. And then you send them away, and then, you know, a week, 10 days later, they come back, they've got the lenses in, you try them on, you adjust them, and then you go away and realise they're not right for you. That's the process. And he said, well, actually, what I want to do is I want to create a pair of glasses that is customisable, bespoke, and will only fit that individual. But in the process of doing so, reducing the cost and having something which is really personalised. And the idea behind the wacky frames there is that you can achieve anything. So what happens is, you look at the circular images, Jaron takes a scanned image of your head. He then uses the points on that scanned image, feeds them into a computer, okay, autonomously, And then what happens is the computer generates different shaped glasses for you to choose. Now, the real cool thing here is that is using an FDM printer, so a really, really low cost printer, less than £500.
FDM printer being a 3D type of printer,
Yeah,
or a 3D
so
printer, a cheap 3D printer.
Absolutely,
Or
cheap
affordable,
3D printer, which
say.
basically layers plastic.
Yeah.
Okay, and you can see that there's two materials: the blue material, which is quite rigid, the orange material, which is flexible. So you've got two different materials there. That can print it in about an hour, and then you can use the data also from that scan to get the lenses cut. Now, when you look at these spectacles, the bridge on the nose looks incredibly sharp. You look at it and you think, wow, that's going to cut your nose open. But actually, it's shaped perfectly to Jaron's nose. And it's so comfortable and it doesn't leave the red mark, which normal spectacles do. So this idea of customization, personalization, we know that that's a big catalyst for disruption. We know that around the world, that's what consumers want. Their demand is changing. They want a product which is theirs, and the beauty of this is they're going to keep it for longer because it's theirs and only they have that particular design. But in this case, Jaron's proven that, and who knows what the next steps are going to be.
I don't know what it says about the shape of his face, so that's what the program pumped out to him, but they are.
Yeah,
destined.
Exactly. The shape of the face is more to do with how the glasses would fit his head. All sorts of different wacky shapes come off there. Yeah, it's quite cool. Jaron's a really, really interesting student, and like I say, the cool thing now is he's taking this, and who knows where he's going to go next with it.
So what we're talking about here is something that just fundamentally empowers people to be able to design, to create, without having to go through traditional large-scale production processes, which is, I guess what you're saying is so empowering for students. It's like a paradigm shift in terms of what they can actually do.
Absolutely. So, like 10 years ago, this wouldn't be possible, but because of the democratization in tools, whether it be software like from Autodesk, which is free for students and free for anyone earning less than £100,000 this particular product is using, or whether it's a 3D printer, which has come down drastically in cost. I was originally a teacher. I remember in 2009, so less than 10 years ago, I bought a 3D printer for £37,000. Now we can get a 3D printer for less than $100. It's just all these things happening at the same time is really quite interesting.
Great, and I think you've got a
Yes.
something lined up to sort of
Something
to illustrate
a
this
little bit different. But again, from that same art school in Glasgow, Saskia and Kevin are currently looking at this concept of a sofa for life. Now, this is just a conventional way of designing. They've gone through the normal design process, but what they've got here is a sofa for life. And the idea is that this has lots and lots of circular feedback loops, upgrades, changing throughout its lifetime, but you keep that sofa forever. Now, what's good about this is they've graduated, they've then decided to not work for the company. They don't want to work for the company, they want to work for themselves. They want to set up their own company. And since the summer, they've used our products, which are free because they're a startup, and they've used them as students. And they've won 9 awards. And this is the real power of students and disruption. I really think that there's a big wave, as I said earlier, coming through who don't want to work for the man. They want to work for themselves, and they want this achievement from themselves because they really do believe in themselves. And the other thing to remember is these guys are digital natives. They don't know a world without digital technology. They don't know what it was like to be pre-iPhone. It just doesn't.
You can't think about it, Steve.
No, yeah. It's so they work in a different way, and their minds operate in a different way to certainly what mine does at my age. And I'm not too far behind them. They're only 10 years younger than me, which is really quite scary.
So it's the power of this and I think what's very interesting is this mindset of, and it's it's present in many industries and fields of actually in today's world of technology, of data, of information, you don't have to go and work for someone if you're wired in a certain way where you want to create yourself and you want to develop something which gives you independence and allows you to uphold certain values or whatever principles or desires you have.
Absolutely. So just hear that, in fact, all of these students that I spoke about, what they did is they took a gap before they decided on what they were going to do. 3 of these don't actually work for anyone still. They took time and thought, you know what, I don't need to rush into a job. Money's not a big thing for me. I want to make the right decision. I want to work out what that right decision is. And I want to pursue a career that's right for me and what I love. And that's just a completely different way of thinking to perhaps what it might have been when you had to leave uni, you had to get a job, you had to leave school, you had to work somewhere because that's what you had to do. The world's changed, and I think these guys are driven more by achievement and aspirations rather than by that financial aspect.
Yeah, so we've got some questions coming in from the online audience, which I'd really want to get to in the limited time we have. I also think we should talk about what else is going on at the DIF, and I am told that my colleague Vicky Deegan has prepared a little bit of a reel of things that are coming up and things that you can watch. So I'm going to pass over metaphorically to Vicky.
Hello, I'm Vicky, and I'm going to let you know which sessions I'm looking forward to most at this year's DIF. So tonight at 8 p.m. UK time, live in the studio, we have the circular economy in 30 minutes with 3 circular economy experts. The Ellen MacArthur Foundation's very own Colin, Emma and Marco. We'll be getting to grips with the circular economy in this 30-minute introduction. We'll be finding out about what is wrong with today's economy. It will also give you the fundamentals of a new approach and a few examples of it in action. Tomorrow at 10:30 a.m, I'm also looking forward to the development paradigm with Harold Friedel, the CEO of Circle Economy. The circular economy as a development approach is currently almost absent from the development discourse. How can we support developing countries towards its implementation? We'll be looking at how the circular economy could be a new developmental approach in emerging markets in Africa and Asia. You can also catch up now on a few sessions already. So one that I'm particularly looking forward to is Understanding Through Storytelling by Jean Bellinger. You can find out why the first rule about systems thinking is you don't talk about systems thinking. And how is it that our best intentions continue to go awry, making the current situation worse or creating new problems that need to be addressed in the future? So get involved, enjoy the DIF and ask questions using the hashtag ThinkDiff.
So we still have time to take questions on this session as well. So use hashtag ThinkDiff to ask those on Twitter. Get in the comments section. Thanks to all of you who are already doing that. We're going to pose some of those questions to Steve in a moment. First rule of systems thinking is you don't talk about systems thinking. One sort of thing I wanted to actually raise you just before we get into audience questions, I think a couple of them kind of actually touched on it anyway, is it feels like this is a multidisciplinary approach to design. Is that fair?
Yeah.
And is that important?
Absolutely. I work with a lot of students who look at mechanical engineering and also studying mechanical engineering. And they're sort of questioning, what it is they're studying. And some of them are modern universities and forward-thinking universities don't just have mechanical engineers in one room. They have mechanical engineers, designers, textile students, dentists. There's a really, really interesting multidisciplinary stuff going on, but this is absolutely all about that. I think as well as this explosion of new technology, we've also got an explosion of the way people collaborate and work together.
Yeah, and I guess we can talk about education trends as well, right? I mean, there's a trend away, at least in some countries, but I think maybe broadly internationally, but certainly in the UK, away from arts subjects, away from...
Yeah, it's a real shame. The UK has got some big problems to contend with in the next sort of 5 to 10 years, certainly in the areas of the arts subject. I was a design and technology teacher, and the subject, because of things like the EBAC, where students must study things like geography and language, is all very good subjects, but what it's doing is it's really marginalising those arts. And there was an article just the other day from Professor Kneebone at the Imperial College London.
Professor Kneebone?
Yes, yeah, it is Professor Kneebone. I just had to just double check that, but yeah, Professor Kneebone. And what he's saying is he looks at medical and surgical students And he's saying, you know, students don't have the dexterity skills that they need to be able to perform operations because of things like they're not using their hands. And, you know, big issue there is the using too much technology. All the stuff we've been talking about today, technology is fantastic, but we need to get that balance. And if we go to somewhere like UCL, they're all for manufacturing, digital technology and that type of thing. But the pedagogy of that is, you know, before you learn to operate a robot, you know, you need to be able to manually operate that machine with your own hands and understand the limitations and the advantages yourself. So a lot still to do there, and we don't want to just completely discount manual process just yet.
So there's some kind of thing here where, on the one hand, there's some practical skills that are not being taught in education structures, and actually the theory itself is, as we sort of discussed earlier, a little bit out of date.
I think, yeah, absolutely. It's just getting that balance. I think what you see in some institutions is repetition of a same process and not, you know, as up to date, or not considering technology as much as they can. It's sort of looking at it and thinking, right, hang on a minute, you know, what's that balance? Am I doing a little bit of everything? Is that pedagogical process correct? And, you know, one of the key things as well is, you know, with all this new technology, where does that fit in with moral and society sort of based issues? It's important for students to be able to consider that. And I'd encourage teachers who are watching this to really, you know, look at these processes of robots, 3D printing, and what sort of impact that's going to have on society as a whole as well.
Right, let's do some quick fire audience questions. So Frank wants to know, how widespread is the idea of additive design, which kind of feeds into what we've just been talking about now, and you know, are all young designers aware of it?
Additive manufacture is, you know, that's, if you look at the Gartner hype cycle, obviously now we're coming out of that, additive manufacture has been embraced everywhere.
Is that an additive manufacture? That's kind of like 3D printing?
3D printing, yeah. 3D printing has been embraced everywhere. Generative design and topology optimization is extremely new. And I'm with the universities that I'm working with, this is just emerging in this sort of last, you know, 12 to 18 months is when it's really just beginning to pick up speed now. And I think the next 18 months is when we're going to get some really, really great, awesome examples. And one of the things that's happening with the students that we're working with is we're also pairing them with industry through something called the Future of British Manufacturing Initiative. And what these students are doing is they're going into SMEs or companies who have got their workflows which they've perhaps embedded and used for quite some time. And these students are looking at how to change that with this new tech. And there's some exciting stuff which I can't speak about just yet, but there'll be some stuff to follow. But these students are really making people rethink what they should be doing and how they've done things for quite a long time.
Fantastic. And so Billy Bob Thornton asks, designers keep telling us that we're all going to produce our own customized stuff soon. Is it possible that you're all caught up on your own excitable bubble and that these new production methods will not stray beyond your circle?
Yeah, this is why it's an exciting time.
Is that kind of a little bit what you're saying is kind of happened? Not actually, it's almost happening in reverse at the moment, that the bubble is an old paradigm that is not actually currently being taught in schools and universities. It's not widespread.
This is it. So what you've got is you've got this new tech, and you've got this new generative, for example, in that case. And what's happening is people with existing workflows and existing companies are trying to squeeze it into what they do. And, you know, what do you take out and what do you eliminate? Whereas what I think is, and this is the answer to the question is, I think what we'll see this definitely in the next, you know, year, 5 years, these students coming through with, you know, they don't have boundaries which manufacturing or anyone who designs and makes things have had over this past, you know, 20, 30 years. And I think that's when we're really going to see what can be done with this when students think in a completely different way to what's been done previously.
Rupert asks, all of the examples so far are part models. I'm not sure when he asked that question, but you know, is this? I guess his question is this ready for assembly modelling yet? I mean, his question is how could you do some generative design today and create a mass scale product, I guess?
No, this is very much in development, and yeah, at the moment the case studies are parts. What students are doing in universities are parts. But what there is an acceleration to be able to get towards assemblies. Assemblies is something that lots of people ask me, when's that coming? But of course, the great advantage with additive manufacture is, it reduces the number of parts. So assemblies don't need to be assemblies anymore. They just can be one part.
Very quickly.
Exactly. So you're reducing the number of parts, simplifying, as Ken talked about last night, simplifying the product, you're simplifying the system. So maybe we don't need assemblies. Of course we will, but that's the idea.
Yeah. I've got two more quick questions for you before we wrap up. The first one is, there's been a bit of interest from the audience, should we say, about the skeletal structure of much of the designs. One person asked, is there any evidence that people want to purchase products that look like skeletons? But actually my question is sort of more like, is more along the lines of why bones? Why base the model on bones?
Well, that's how we've evolved. And, we've evolved in a way that it's not that we've said we're going to do, bones. This is, like I said, form follows forces, and we've evolved in the way we need to withstand forces. And it just so happens that they look like bones. Using that same algorithm, it just so happens that that looks like a bone as well. The real sort of thing to get your head around is we've done things mathematically for quite some time where we'll take a shape and make it longer, or we'll have quite geometric looking things because that's how we design and make things. But if we look back before the first industrial revolution, we had artisans who didn't do that. They made things in a bit of a different way. And it's because, I guess, of that industrial revolution and because of machines and because of mass production that we've got into this mindset of, it doesn't look normal. But actually, who knows, that bone-like structure might have been a little bit more normal before we started talking about these revolutions.
And maybe finally, and it's kind of a big question to finish on, and you don't have any time. You don't really have any time. You don't have any time to answer it. But where does the circular economy fit in this?
Yeah, so absolute great question. Circular economy in this case, if you think about, it's got to be in them feedback loops. Okay, it's got to be in the feedback loop. How do we take data from a design in the generative system and feed that back into iterate and improve something? But as a company, as Autodesk, as an individual, circular economy is certainly very much at my heart there. And I think generative design on its own is not going to solve all the problems in the world. I think it's going to really help us with a small part of that, and it's how the system that brings everything together with all this new tech. But I certainly think generative design has a massive part to play in being able to create products and systems and services that can create a circular economy.
Thank you, Steve. So we've heard today about how new technologies are allowing designers to reconnect with the production processes. Specifically, students are able to do incredible things by using a design method that's really based on nature and bones. So thank you so much for joining us and for all your questions and comments during this session. Thank you again to Steve for sharing these stories with us today. I really do encourage you to check out everything else that's going on at the DIF. Tonight at 8 o'clock GMT, we have the circular economy in 30 minutes. If you've ever wondered what it is, we've been talking about it a bit today. We're going to talk about the fundamentals and some examples of it in just 30 minutes from 8 o'clock GMT. Tomorrow, we're also releasing a podcast on safe and circular material choices. And don't forget, you can watch most DIF sessions back almost immediately after they're live, including this one. Yesterday, we had our launch party where, similar to where we're talking to today about reconnecting with production processes, we had people talking about reconnecting citizens to the economy and designers to the material choices they make. That was Liz Corbin from Materium and Ken Webster. But thank you so much for joining us today, and please do continue engaging with us, even in our comments section or by using #ThinkDiff.